CNC machining, or computer numerical control machining, is an advanced process where computers control the movement of machines to shape materials. Unlike traditional manual machining, CNC ensures precision by following a digital program that dictates everything from speed to direction, thus ensuring precision and achieving tight tolerances. This makes it ideal for producing complex parts with high accuracy and consistency. So, how does CNC machining come into play in cooling plate development? CNC is used to create components like coolant channel plates and ports, crucial for managing the flow of cooling liquid. These parts can be made without the need for molds, making CNC perfect for prototype development. The high precision of CNC also ensures the tight tolerances needed for reliable, leak-proof connections in coolant ports. Speaking of which, do you understand the benefits of the CNC process for cooling plates? CNC machining offers several key benefits when it comes to developing cooling plates, making it an ideal solution for prototype production. 1. Faster development. CNC machining speeds up the development process because it doesn't require mold creation. Traditional mold development can take 25 to 45 days, but with CNC, production can start immediately, saving valuable time. 2. Cost savings. Though CNC machining might take a little longer per cycle, it saves money by eliminating the need for expensive molds. This makes it a more cost-effective option for producing cooling plate prototypes, especially for smaller batches. 3. High precision. CNC machining provides excellent precision, typically achieving size tolerances of 0.05 millimeters. This level of accuracy is much better than stamping with soft molds, ensuring that cooling plate prototypes fit properly in battery pack trial assemblies. 4. Material flexibility. CNC machining can work with various engineering materials, including aluminum, copper, and even plastic. This allows for more options in material selection, depending on the needs of the cooling plate. In short, CNC machining is a good choice for cooling plate prototypes because of its many advantages, including fast production speeds, low cost, high precision, and material flexibility. By eliminating the need for mold development, CNC machining streamlines the production process, enabling you to save time and money. Whether you're producing small batches or creating one-off prototypes, it ensures you get high-quality, high-precision results that accurately and efficiently meet the specific needs of your project.